Have you ever wondered how cutting-edge AI models like DeepSeek-V3 are actually built? Well, today we are diving into its codebase because it's open source. We will explore how it processes data, how it structures the training or learning, and how you can even host it yourself. Let's get started. DeepSeek, founded in 2023 by Liang Wenfeng, began actually as a hedge fund firm, but recognizing the transformative potential of generative AI, they ventured into the AI development business. And despite facing challenges like limited GPU resources due to geopolitical conflicts, they embarked on creating DeepSeek-V3, which is actually aiming to revolutionize AI with its efficiency and cost effectiveness. And despite these hurdles, DeepSeek continued with the development and created a model which made waves in the AI community and also the stock market. And DeepSeek's V3 is actually a model that is based on mixture of experts language model, and it has, instead of a normal attention layer, it has a multi-head attention layer, MLA. We will see what that means at a later point. But this architecture enables actually DeepSeek-V3 to process human-like responses more effectively than its competitors. And in my last video, I actually made a big comparison between ChatGPT, Claude, and other AI tools, of course also DeepSeek. If you want to have a look at it, make sure to check it out. Okay, enough talking, let's have a look into the code. Okay, we are starting with a very simple intro. We want to check out this GitHub repository. It's the V3. Of course, there is the R1, but in this video, we will only focus on V3. Okay, if you don't have any experience with GitHub or Git or code, Python code in general, make sure to check out this video above where I talk about how you can start to program with zero experience. Okay, but for now we will just check out this repository. I already have downloaded it over here. And of course, like in the last video, we will start with the README file. And here I have opened it already, the README file. And in this README file, you can actually see that it's also comparing against other AI models that exist. So for example, Llama, Gwen, ChatGPT or GPT-4o. And this is a common practice. And it's also, you can see here is actually also the paper of DeepSeek, so of the V3. It's quite interesting. I haven't read through everything, to be honest, but through most of it. It's very interesting if you want to go deeper, but we are not going so deep today. And what we will do now is we will go right into this inference folder, because the other are just README for the weights, if you want to download the weights, and here the figures that are mentioned here. Nothing interesting. So we will start with this inference folder. And what you can see here are some MISC functions. So for example, here this convert functionality, also this FP8 cast to BF16. We will also not go deeper into that, as well as, for example, this kernel functionality, which is basically a way of low-level functions to calculate this quantization. And if you want to install it locally, of course, you need to install these requirements. I will show you how this is possible at the end of the video. But now let's come to the most interesting part, and that's actually this model. And I was quite surprised actually that only with these few lines, more or less the model could be created. Of course, a lot of magic also is in these weights and in the training. But this basically is the architecture of this famous V3. We have never seen it in ChatGPT, so we don't know what's really behind it, although they have also papers. We can assume it, but we don't know for sure. Here you can very transparently see it. And like always, I would recommend to start with the main. So here is the main function basically of this model. And what you can see here is that they are using this bfloat16 or this FP8, so floating point 8. And I will explain it to you. So the normal length of a float data type is actually 32 bits or 4 bytes. But you can actually do you can reduce the precision and then you have a float 16. And they even use a float so a floating point with an even smaller precision, so floating point 8. And it's very similar to this bfloat16. If you are interested in this topic, I have explained it a bit more in detail in my blog post, and of course I have also other links for more detailed explanations. But in the code, for example, it's reflected over here. Okay, then skipping over the seed, here are nothing special, just the arguments for the model. We can briefly have a look at it. Basically the number of heads, the vocabulary size, and so on is probably quite interesting. But we will have a closer look into it later. But for now, we will look into this transformer, which is basically the whole architecture of the whole model. And in PyTorch, it's always like that you have this class model, and transformer is basically a subclass of it. And so it derives from model and of course has all the functionalities from it. So for example, you can also here see the init functionality. And what you always need to do first is that you initialize also the base class, so this module. And you are doing that over here, like super init. And then you would have the next step is a forward class, which will take all these tokens that you have entered or provided in some sort as an input and will return basically the logits as an output. And that's also the most important step, I would say. But first, let's have a look at the initialization. So first, I don't want to go into everything, but of course you have two variables, world size and rank here as set as a global variable. Okay, yeah. But here is the interesting part where we come to the embedding. And actually, what's the embedding? So basically, you probably have heard that one sentence, for example, is split up into different tokens. But that's not the whole story. The whole story is that these tokens are also translated into numbers, basically. So of course you cannot calculate with words, and therefore you have a very a big dictionary or vocabulary, and you will search up basically every word, and you will receive an embedded code for it. So it will be embedded vector. And for example, if you have two very similar words, for example, ship and boat, they are more or less the same. So you would have a vector that is quite similar in more or less same direction. So I don't have the time to draw kick-ass animations, but there's actually a very good video about this topic if you want to know how in general transformer networks work. I can recommend it, and I also have it in the description, of course. Okay, now we basically understood what this embedding does, and now we have a list of layers. Yeah, it's module list, and we will fill this list by appending with this block. And what is actually this block? It's also a class described here. What is quite interesting is that it basically contains only of 4 things. So this attention layer, the first attention layer, then you have this feed-forward network. I'm reading here, by the way, description. And you have a normalization after that. And you might now ask, why are we actually using this root mean squared error for normalization in this context? Yeah? Because this is actually the simplest indication of an error, and it's a standard procedure. If we go into this class, we will also see nothing special happens here, only calling this read mean squared error function to normalize everything, to normalize the whole layer. combination with attention layer and feed-forward network works, I would also recommend you to have a look into this video, because it's quite interesting and I cannot explain it in that much depth. But I think it's very important that we talk about it, because this is actually the heart of the whole network architecture. But what does this attention layer actually do? So you have a lot of tokens. Each token is basically a word, and you are refining with every attention layer. You're refining the matrix, basically, the list of vectors of all the words. And that's important. Why? It depends on the context. For example, you have the word model. It depends. If you are saying it in a machine learning context, it's completely different than when you are saying it for fashion, for example. And then, as a next step, we have this feed-forward network. And in this network, the vectors are not talking to each other. They are only basically projected to the next layer. And of these layers, you can see that in the model arcs, you can see how often that is done, n layer. And you can search up n layers, and it's 27 times where you have this attention layer, including this feed-forward network. Okay, good. And then as a next step, you are also normalizing it. But now let's come to the more interesting part, which is actually what happens when you are predicting the next word. So when you're using the network, basically. So when you're calling the forward function. And here it's the same as above. You have basically, it's what I talked about. You're embedding the tokens. I don't know what actually H stands for in this context, but I would assume it's probably hidden stats. And here you're using basically the forward function within these layers that you have just created in the init functionalities. You are normalizing it again. And this head is simply this column parallel linear, which is basically only putting the matrix into a linear transformation. If you forgot how a linear transformation works, I have a small animation here for you. And then you end up with basically a softmax logits. What is softmax? I have also a small animation over here, which should be self-explanatory. But in general, what is so special about this DeepSeek code? So it has a multi-token parallelization, what means it can actually produce these words or the output faster because it can process it in parallel. And you don't have to wait for the other ones to be finished. That's also another way to adapt to this GPU shortage. Okay, and now let's come to the crucial point. You want to run this code locally. And for this, you actually have a small section in this README file, which is basically saying how to run locally. And here you have a detailed description, and basically it says install the dependency, of course, and clone the repository, and you need to make sure to have it also with git lfs. And of course, it would be great to see now this model in action. What you actually only need to do is to download these weights, and the weights are saved here as safe tensors in Hugging Face here. You can just download it. You can check out this repository, and of course you need to enable this git lfs, but it's actually 260 gigabytes and I don't have that much space left because I'm filming too much. But there are actually far better ways to handle this, and I will talk about this now. But let's have some closing words. DeepSeek's journey from a hedge fund to an AI pioneer is actually a testament of innovation and resilience. By understanding the architecture and the code of DeepSeek, you can now harness its power for your own projects. Simply check out DeepSeek's repository for more details. And don't forget to like and subscribe for more AI deep dives. But you have now seen how complicated a local setup can actually be. And therefore I will talk in the next video about a more independent and simpler way to access large language models. because these big black boxes like ChatGPT or Claude are very limited and not so attractive for us engineers, software engineers, because we have the freedom to choose whatever model we want to use and whatever model is right now hot. And if you want to see how I generated this background image with a simple API call, let's watch the next video. But that's it for now. Thanks for watching and have a good one. Keep coding. Peace out.
You think that this life's made for a king.